In this video, you will learn about the examples presented in the Parent Kit booklet for grades KG to 2. We will walk you through all the pages and purpose of including each of the examples. The worksheets show how basic operations like addition, subtraction, multiplication are introduced to QMath students. Students do not learn addition as a new concept with no links. Instead, they visualize it as an extension of counting and grouping. Using objects that are familiar to them, they see the process of addition. This helps them attach objects to abstract numbers like 5 and 2. Also, visualizing helps them create mental models of addition. Once children get comfortable with the visual models method, we move on to using number lines for adding and subtracting. This way, we move a step away from using objects and a step closer to using just abstract numbers. Here, children can actually progress forward to add and backward to subtract. They understand the value of these abstract numbers. With this sheet, they see that there are many different ways to get to a number. One of the addition statements to get 4 as a result could be 2 plus 2, and the same number 4 can be reached by subtracting 2 from 6. They learn that there may be several ways to get to the solution. They are introduced to the concept of multiple approaches. As the idea of multiple approaches takes root, it encourages the child to evaluate the best or most optimal route, a key skill for later years. The thought of word problems is often daunting to children, but at QMath, these problems are introduced to children by creating a scenario that they can relate with. They see that math is not just numbers and pictures, it is all around them. Students learn to master application of concepts by comprehending sentences. They then deduce which operation needs to be carried out to arrive at the answer. This enables them to move beyond mechanically following addition or subtraction procedures. This ensures that their ability to reason is challenged sufficiently. Students see that multiplication isn't some new idea. They visualize multiplication as an extension of counting and addition. They recognize 3 multiplied by 2 means 2 plus 2 plus 2, which is just repeated addition of 2, a concept that they are already aware of. They now realize that they don't have to rely on their memory of 3 times table. By grouping the objects, students can see multiplication as repeated addition. This builds their intuitive understanding of multiplication faster. They then extend their understanding of the multiplication algorithm with various models like dot arrays, allowing them to deal with large numbers and even enabling them to create multiplication tables on their own. They can visualize multiplication as an extension of addition and understand why 4 times 3 is equal to 3 times 4. This clarity in understanding multiplication helps children to deal with complex ideas like factors, multiples, and primes with ease. Sheets like this also help in building comprehension skills through word problems. Students practice translating a word problem into a mathematical statement. This is followed by exercises that require forming word problems with given images or mathematical statements. Using color counters, students see how 3 times 15 gives the same result as 3 times 10 plus 3 times 5. This helps them understand why the column method of multiplication works. It is after this step that they learn the algorithm or procedure for the column method of multiplication. This means that the students don't need to memorize it. This is what we mean when we say that the students understand why before they learn the what. Once students understand the algorithm for multiplication, they can extend it for larger numbers with ease. A child in UKG solves these kind of questions on subtraction using the tab. It is pretty clear that to answer this question, the student counts the number of fruits the monkey and the elephant have individually and subtracts the two numbers. Using these visual representations, the subtraction operation is made more intuitive to him. That is, of course, just one way of looking at the problem. If a student has not learned subtraction yet, he can still answer these questions through counting without consciously realizing that he is performing the subtraction operation. Because of the way these questions are designed, the student can see that there is a one-to-one correspondence between the two animals and their fruits. So it soon becomes clear that he just needs to count the gaps. This discovery in fact allows him to answer these questions faster, even if he knows how to subtract numbers. Students are exposed to the concept of symmetry early on through novel objects like flags. They do not learn the formal definition of symmetry, but try figuring out what symmetry means by carefully considering the image which is the odd one out. The abstract concept of symmetry is simplified through these exercises. Students start seeing that something is unique about figures that are symmetrical without being explicitly told what it means. The questions are designed such that it is easy to spot the images that stand out. This exercise is introduced to kids as early as kindergarten. Soon students will start seeing problems of a higher difficulty like these. These questions allow them to visualize symmetry. They may even try to use actual mirrors to understand the images that mirrors cast. Children identify patterns and understand shapes in an engaging way. In this exercise, all the shapes in the options are the same as the ones in the question. The student now thinks beyond just the boundary of the image and looks at the pattern within the shape. A combination of the boundary and the pattern is same only in case of the square. This is something that students figure out after a few attempts. Here are some of the puzzles that students of grades KG to 2 receive. Try to solve these puzzles yourself. This will help you in case parents ask you for the solution. In the first puzzle, children analyze shapes in different ways to get to the answer. Most children would just count the most apparent squares in the puzzle and conclude that the answer is 6. If a child answers 6, push the child to think beyond. Questions like this teach children to be thorough and look for the not so apparent information. Upon careful consideration, most children can see the 2 more squares that they missed. This makes the answer 8. This question also helps reiterate the difference between a square and a rectangle. In the second puzzle, children spot patterns to figure out the missing numbers. After a few trials, they see that the sum of numbers along any line passing through 5 is 15. Like 7 plus 5 plus 3 is equal to 15, 6 plus 5 plus 4 is equal to 15. So to get to 15 as the sum of this row, we need to fill in this box with the number 9. That is, 9 plus 5 plus 1 is equal to 15. Similarly, to get 15 as the sum of this row, we need to fill this box with the number 2. That is, 8 plus 5 plus 2 is 15. The third puzzle can be solved in many ways. This is one way to solve this puzzle. Why don't you try another method? Children see that there can be multiple ways to approach the same problem.